Hello everyone, we are working in Chapter 9, Section 9, introducing the quadratic formula. And we'll be talking more about this in, I think, the Example 5 video, one of the later videos. But I'm going to summarize what we've done so far. We talked about solving by graphing, we talked about solving by factoring, we talked about taking the square roots, and then in the last section we introduced the idea of completing a trinomial square so that we can then take the square root. So we're going to wrap this all up with the final method, which is the quadratic formula. We're just providing tools for you to use in different situations. And like I said, that's going to come up in one of the last examples in this. The type of problems we're going to do is we're going to look at quadratic equations and kind of choose which method to use. We'll get to there. I'm going to not record the how do we get the quadratic formula video. We'll talk about that in class and I'll go through it a little bit. It's one of the things that I kind of go through in my Algebra 2 class, and I know it's in, or I don't know, I should check, but I think that I recorded the video for that, for like where it comes from. So I'll see if I can link that for those of you who do want to know. The thing is that I don't want you to think that this comes from magic. Basically, and you can look, it's in the book on the first page of this section, which the page number is escaping me right now. I'm sorry. But essentially what happens is you take the standard form, ax squared plus bx plus c equals 0, and then you complete the square with it. And it's a little tricky because you're not using constants that we know. In the book, there's a side-by-side example where like you're using like numbers, and in the other right next to it you're using the parameters a, b, and c. But essentially you complete the square, you do some common denominator work, and you take the square root, and then you solve, and you end up with this, the quadratic formula. So what this means is that if you have something times x squared plus something times x plus something. Now look at this example. In this first example, I'm going to let a equal 2, b equal 3, and c equals -5. These are called parameters, okay? They're not variables, parameters. The a, the b, the c. I'm just using the letters to represent them so I can look for the pattern. Essentially what I'm going to do is replace each of these, the b here, the b here, the a here, the a here, and the c, and I'm going to just replace or substitute into this formula. Now, the book, and every math teacher that I know, except for Miss Corbett, because she and I have talked about it, starts off by just copying this and start replacing things. I'm going to do it slightly different. I'm going to break it into pieces, and essentially the idea is this part that's under the square root, that part is called the discriminant. We'll talk more about that in one of the later videos. I actually seriously considered doing that example first. I think it would have been better if Dr. Berger would have rewritten it, but that's why he gets paid more money than I do. We're going to do this b squared subtract 4ac first, and then we're going to do the whole thing. The only thing is that I'm not going to like work under the radical. I'm going to take care of that, all of this under the radical first, and then I'll substitute. Now, one thing to point out is, like I've been saying, you always get two solutions. How do I get two solutions? Because one of them has a plus sign and one of them has a minus sign. This plus or minus tells me that I actually have two formulas here. Negative b plus the square root of this over 2a, and negative b minus the square root of this over 2a. So don't forget, you always get two. So let me show you what I want you to do for this one, and please remember that this is what you're going to be showing me, all right? So first of all, I'm going to take care of this part, the b to the second power subtract 4 times a times c. I'll see if my marker holds out. So my b is 3. I'm going to replace everything using parentheses. Whoops. Almost started to write b again. And now it's important that you use parentheses, because in later problems the b might be negative. This 5 is, well, it's going to be adding -5, so that's why I got this part. The c is -5. Subtract 4, the a is 2, and like I just said, the c is -5. All right, so now I'm going to take 3 to the second power, which is 9. I can go ahead and multiply all of this together, and then I'm going to subtract, right? 3 to the second power, 9. Subtract. 4 times 2 is 8, and 8 times -5 is -40. And when I subtract, that means adding the opposites, so this is the same. And you wouldn't even have to write this, I'm just writing it for you guys. This would be the same as 9 plus +40, which equals 49. Now, later we're going to, the first couple of problems, these are all going to be positive numbers, all right? And in this example, hopefully for this example, I don't think any of them are going to be different. But in this example, they're going to be perfect squares. All right, so positive perfect squares. That's not always going to be the case, and that'll be an important idea as it comes up. What happens if it's not a perfect square? What happens if it's not positive? So we'll get to all that in later videos. Now I'm going to do the quadratic formula. X is equal to the opposite of b. Don't forget, you're going to use parentheses. B is 3. Plus or minus, that means I get 2 of them. The square root of this number. All of this that I just did is what ends up right here. And I'm going to divide that by 2 times a, and my a is 2. So now, I've got 3 things to do, and then I need to see if I can go further. 3 things I'm always going to do, and sometimes that'll be it, but sometimes you have to go further. I need to find the opposite of this, I need to find the square root of that, and I need to multiply that by 2. So I get x equals -3 plus or minus, that means there's 2 of them, don't forget, the square root of 49 is 7, and 2 times 2 equals 4. Now, if this was not a perfect square, I would not get, well, if this was not like the square root of 49, I would not get 7. If it was like the square root of, let's say, 40, then I'd have to simplify, but I'd still end up with a radical here. And sometimes that means that I can't do anything further. In this case, I can't. This tells me that I've got x equals -3 plus 7 divided by 4. -3 plus 7 is 4. 4 divided by 4 equals 1, so I get x equals 1. My other solution is going to be x equals -3 subtract 7 divided by 4. And -3 subtract 7 is -10. And -10 divided by 4 can reduce to -5/2. And you can leave it -5/2. That's okay. You don't have to change it to a decimal. All right. So let's do another one. I'm going to grab a different marker here. Let's see if this one's a little bit better. All right, so sometimes you have to rearrange it to put it in standard form. That's okay, it's not a big deal. I have, and you need to, I should have mentioned this earlier, this only works if the standard form is equal to 0. So you have to set it equal to 0, which is really important. Remember that from factoring. So I'm going to add -2x to both sides, move that over to the other side, and get 0 equals x to the second power, subtract 2x, subtract 3. And it doesn't matter if it's something equals 0 or 0 equals. It doesn't matter. The whole thing just, they have to be equal to each other. So if I look, my a, I don't see anything. That means it's the hidden 1. My b is -2, and my c is -3. When I get to this problem, I don't have to do that step. Excuse me. All right, so first I need to find this. It's called the discriminant, but like I said, we'll talk more about that in a later video. Don't forget to use parentheses. My b is -2. Why is that different? Because, and I'll write it up here, -2 squared equals -4. but negative 2 squared, when I put the negative 2 in parentheses, equals positive 4. This means a negative times a negative, which is what I want. I want negative 2 times negative 2. If I don't put parentheses around it, that means the opposite of 2 squared, which is the opposite of 4, negative 4. So don't forget that. A is 1 and B is negative 3. Again, putting everything in parentheses. Square this, multiply all this, and then subtract. Negative 2 squared, like I just said, is 4. 4 times 1 is 4. 4 times negative 3 is negative 12. And 4 subtract negative 12. Subtracting means adding the opposite, so this becomes 4 plus 12, which is 16. And that's nice. I like that. It's not always going to happen. Why is it nice? Because that's a perfect square. Now I'm going to use my formula, and I'll sneak it back here real quick so you can see it. B to the negative b plus or minus this b squared minus 4ac, which is what I just found, all over 2a. So x is equal to the opposite of b, parentheses. My b is negative 2, so the opposite of negative 2. Plus or minus the square root of what I just found, 16. Divided by 2 times a. And my a is 1. Forgot where I wrote it. Find the opposite, take the square root, multiply by 2. You're going to do that every time. The opposite of negative 2 is 2. The square root of 16 is 4. And 2 times 1 equals 2. And now I can break this into two equations. Looks like I can simplify this. So I've got, and I'm gonna write it over here. X equals 2 plus 4 divided by 2. 2 plus 4 is 6. 6 divided by 2 equals 3. So there's my first answer, my first solution. The other one is going to be 2 subtract 4 divided by 2. 2 subtract 4 equals negative 2, and negative 2 divided by 2 is negative 1. Alright, let's do one more for this video, but you'll be seeing lots of examples of the quadratic formula. This one's in the form that I want. It's standard form, and it's set equal to 0. So I'm just going to identify a is going to be negative 3, the b is going to be 5, and the c is going to be 2. First I find my discriminant, that's what we call it. B is 5, so I write 5 to the second power. Subtract 4, my a is negative 3, and my c is 2. Square this, multiply all these, and then subtract. 5 to the second power is 25. 4 times 3 times 2, 4 times negative 3, I should say, is negative 12. And negative 12 times 2 is negative 24. So I'm going to subtract negative 24. And when I subtract, I add the opposite. 25 plus 24 equals 49. So there's 49 showing up again. And like I said, in this example, I'm going to end up with perfect squares just to make everything kind of nice. Here's my quadratic formula again. I'll show you one more time. It's the opposite of b, which is the opposite of 5, plus or minus the square root of what I just found, 49. And I'm going to divide by 2 times negative 3. So just like every time else, find the opposite, take the square root, multiply by this by 2. Whatever the a is, multiply by 2. So I get negative 5 plus or minus 7 all over negative 6. And I'll come over here. Negative 5 plus 7 divided by negative 6. Negative 5 plus 7 is 2, and 2 divided by negative 6 reduces to negative 1/3. So there's one of my choices, or one of my solutions, not a choice, solution. The other one's going to be negative 5 subtract 7. Notice how I broke these. Look at this one. One's plus 4, this is subtract 4. This is plus 7, this is subtract 7. Remember, you always get 2. Negative 5 subtract 7 is negative 12, and negative 12 divided by negative 6 is positive 2. Okay, in the next video we're going to talk about what happens if you don't get a perfect square and you have to do something else.